Have you ever thought about how math is kind of like a universal language? No matter where you are in the world, 2 plus 2 is always 4. But for any language to work, everyone has to agree on the rules. And that's what the order of operations is. It's the grammar that makes sure we're all speaking the same mathematical language.
So, let's dive right in with a little puzzle. Take a look at this. 2 plus 5 times 4. Seems simple enough, right? But here's the catch. Depending on how you decide to solve it, you can actually end up with two totally different answers.
And this is exactly where the confusion comes in. If you decide to add first, you get 7, and 7 times 4 is 28. But if you multiply first, you get 20, and 2 plus 20 is 22. Both methods use perfectly good math, but they lead to completely different places. So, which one is correct?
This is the big question, right? How do we decide? And maybe more importantly, how do we create a system where everyone on the planet gets the exact same answer every single time? I mean, think about it. Without a shared agreement, math would just be total chaos.
Well, thankfully, there is a solution. Mathematicians long ago agreed on a universal set of rules to avoid this exact kind of confusion. It's a standard way for all of us to approach these kinds of problems, so we're always on the same page.
And that agreement is what we call the order of operations. It's really just a simple set of rules that acts like a recipe, telling us the correct sequence to follow. This guarantees that for any problem, there's only one right answer.
The rules follow a really clear hierarchy, kind of like a ladder. You start at the top with anything inside parentheses, then you move down to exponents. After that, you tackle multiplication and division. And finally, you finish up with addition and subtraction. Let's break down each one of these steps.
Okay, let's start at the absolute top of the food chain, grouping symbols. You can think of these as the VIPs of any math equation. They get to cut to the front of the line. Parentheses, and their cousins the brackets, are basically big, flashing neon signs in an equation that shout, "Solve me first." They create a little mini problem inside the bigger problem that you absolutely have to solve before you touch anything else.
So, for example, look at this problem. Our eyes might naturally want to jump to the multiplication, but those parentheses completely change the game. They're giving us a direct order. Deal with what's inside this group first, no exceptions.
So we follow that order. We look inside the parentheses and solve 4 plus 5, which is 9. And just like that, the entire group simplifies down into a single number, which makes the whole problem much less intimidating.
With that group taken care of, we're just left with a simple multiplication. 10 times 9 gives us 90. You see how those little parentheses completely directed the flow of the problem? They're the key to getting the right answer.
All right, so once you've cleared out any parentheses, what's next on the priority list? Well, that would be exponents. These are essentially a shortcut for repeated multiplication, and they carry a lot of weight.
Yeah, that little number you see floating up at the top of another number, that's the exponent. It's just a compact way of saying multiply the base number by itself this many times. Right after you've handled parentheses, these guys are your next priority.
Okay, check this one out. We've got multiplication and an exponent sitting right next to each other. Now, the rules of our hierarchy are crystal clear. The exponent has to be dealt with before you can do the multiplication.
So we start by calculating 5 squared, which is just 5 times 5, giving us 25. By simplifying that exponent first, the rest of the problem becomes incredibly simple to solve.
And now it's just a straight shot to the finish line. 3 times 25 is 75. It's a really straightforward process, as long as you respect the order.
All right, now we get to the operations we see all the time. Multiplication, division, addition, and subtraction. And with this next piece of the puzzle, we can finally go back and solve that mystery we started with.
This is probably the most famous rule of the bunch, and it's the one that comes up the most in everyday math. Just think of it like this. Multiplication and division are on a team, and they always get to go before the addition and subtraction team.
So let's circle all the way back to our original problem. Now that we're armed with this knowledge, we can see there's actually only one correct path to the answer.
We scan the problem, and we see addition and multiplication. Our rulebook says multiplication has priority, so we have to calculate 5 times 4 first, which is 20, before we do anything else.
And now, we just complete the final step. 2 plus that 20 gives us 22. And that's it, the single correct answer. It turns out that second person was right all along, because they followed the rules.
Okay, but what happens when you have a tie? You know, what if you have two operations from the same team in one problem? For instance, what if you have both multiplication and division? Which one goes first?
Yeah, this is a classic spot where people can get tripped up. Do we multiply first, or do we divide? They have the same priority in our hierarchy, so we need one last simple rule to break the tie.
And as you can see here, the order you choose makes a huge difference. If you work from right to left, your answer is 2. But if you work from left to right, you get 50. Those aren't even close. So which way is the right way?
The tiebreaker rule is super simple. Whenever you have operations with the same priority, you just solve them from left to right, just like you're reading a sentence. This applies to both multiplication and division, as well as addition and subtraction.
And there you have it, the whole shebang, your complete toolkit. First, anything inside parentheses. Second, exponents. Third, all multiplication and division, moving from left to right. And finally, all addition and subtraction, also from left to right. That's the code that keeps the language of math consistent for everyone, everywhere.
So when you think about it, the order of operations is so much more than just a random list of rules to memorize for a test. It's the foundational logic, the very grammar that makes all other math, from your household budget all the way to complex algebra, even possible. It's the silent, consistent code that keeps our entire world of numbers in order.